This video is Module 11, Part 2 of 2 for the Intro to Networks version 7 for the Cisco Netacad CCNA series. We're going to continue our IPv4 addressing in this module. The module objectives for this video will be to look at how we subnet an IPv4 network. A note on this video, I'm going to be talking about subnetting a v4 network at a high level. I have videos in the description below, video links in the description below that go into detail in those videos on how to subnet an IPv4 in the 4th octet, how to do it from an advanced standpoint, a video on doing VLSM, and the ANDing process. So check out those videos. I'm going to cover this from a material standpoint at a high level, just so you know, and you can check those out to get more in-depth coverage on those. Networks are easily subnetted at the octet boundary of 8, 16, and 24. If we use a longer prefix length, it decreases the number of hosts per subnet. So on a /8, we have 16 million hosts, 16,700,000. If we increase the prefix length of our subnet to 24, we only have 254 hosts. On this table here, a /8 on the left-hand side would give us 256 possible subnets and 65,000 hosts per subnet. If we slide that subnet all the way over to a /24, that gives us 65,000 possible subnets, but only 254 hosts per subnet. So as you can see, as we move the subnet masking from the left to the right, it decreases the number of hosts and increases the number of networks or subnets that are possible. So these are the 6 ways you can subnet a /24 network. You can have a 25, a 26, a 27, a 28, or 29, or a 30. We're just moving the bit place one place. We're just increasing the bit place. Here on the first one, if we subnet at the /25, that would give us 2 subnets. We're splitting a /24 in half if we are moving it to the 25 range. And that gives us a 126 hosts per subnet. But now we have 2 subnets. If we move it one more, we get 4 subnets with 62 per host, or 62 hosts per subnet, and on down until we get down here where we can have 64 subnets, but 2 hosts per subnet. And if you check out my videos in the description below, I go more in depth into that and how that works. I also have a Google document which gives you a chart on, makes this much simpler to look at, and it's a chart on looking at all the subnets by bit place and all of the hosts and how many networks and how many hosts you get per bit place as you move it through from /2 all the way up to a /30. So if we subnet a /16 and a /8 prefix, this table highlights all the possible scenarios for subnetting a /16. And again, check out my videos below. I'll also put a link to the Google Doc down below in the description for you, and you can check that out as well. It's a much bigger table. It doesn't have the network addressing here, but it does make it a little bit simpler than what's shown here. We can create 100 subnets with a /16 prefix. This is how you can do the borrowing and the 1 bit, and 2 to the first place is 2, 2 to the second place is 4, and on down if you do the math. There are some people that can do the math in their head and do this subnetting. That's great. I cannot. And so in my video, again, in the description below, I show you a simple way to do it on paper, where you can do it without having to do math in your head, and you can practice it anywhere. As long as you have a piece of paper and a pen or a pencil, you can do subnetting quickly and easily. This is creating 1,000 subnets with a /8 prefix, and it shows you how to borrow the bits. 2 to the 7th place is 128, 256, 512. And hopefully you're starting to see the numbers because we're using binary. They're doubling 2, 4, 8, 16, 32, 64. It's all based on powers of 2. Subnetting to meet requirements. When we subnet private versus public v4 address spacing, enterprise networks will have usually an internal network, typically using private v4 addresses. Typically, an enterprise network is going to be given a range of IP addresses to use by their ISP. So you might get anywhere from 2 to 4, maybe static IP addresses from their ISP. Those aren't going to go very far in the enterprise. So what they do is they make their whole subnetting scheme with V4 inside their internal network. A DMZ is when a company has forward-facing or internet-facing servers. Devices in the DMZ use public IPv4 addresses. So we make this DMZ, demilitarized zone. It's a military term, demilitarized zone. What we do is we put our this might be web servers here, and we put them out that's accessible to the internet, but they're not going to have the same IP addressing as our internal network or our intranet. So that if someone does from the internet get in, which they are going to need to get in to ping in this case, we're going to say this is a web server, and someone is pinging this web server through the router, they're going to have access to that server to be able to pull web pages. And if they somehow gain access to that, they're not going to gain access to the rest of the network. So a company could use a 10.0.0.0/8 and a subnet on the 16 or 24 network boundary. So they could use a private addressing internally here that's not going to be able to be visible to the internet. And the DMZ devices would need to be configured with public IP addresses. Another thing that you want to keep in mind is minimizing unused host V4 addresses and maximizing subnets. So there's considerations when planning. You want to make sure that you're not giving a larger subnet out than you need to when you subnet. So if you only need 2 subnets, you don't want to make it a /29 where you have 29 subnets. If you only need 2 subnets, you just go ahead and subnet it into the /25 where you have 2 subnets. If you need 126 hosts or less. If you only need 2 hosts, for example, let's say that I only need 1 IP address or 2 IP addresses to go between 2 routers, and I want to set a separate subnet between those 2 routers, I could use the /30, and you'll learn more about that with VLSM or virtual link subnet masking. And I'm going to subnet in the /30 range so that I could have 64 subnets, but I really only need 2 hosts. Now, that's a lot of extra subnets, but at the same time, I don't want to use up a lot of hosts, and you'll see how that comes in handy in the VLSM. For now, just know that you want to keep in mind, you want to maximize your subnets and your host and find a good balance there. This is an example of efficient V4 subnetting. A corporate headquarters has been allocated a public network address of 172.16.0.0/22. That's a 10 host bits by its ISP, providing 1,022 host addresses. There's 5 sites and therefore 5 internet connections, which means the organization requires 10 subnets, with the largest subnet requires 40 addresses. So it will allocate 10 subnets with a /26 subnet mask, so that each one of those can get out to the internet. And most likely in this case, you're just going to go ahead and get an IP address. They're going to give you a range, and you're going to say you need, here 1, 2, 3, 4, 5. So you're going to tell your ISP that you need a minimum of 5. They might sell you 10 static IP addresses, and then you would sign your external gateway to those numbers, and then you would have your internal numbers as something separate. See, here they're saying 172.16.1.64. If it were me, in a practical sense, I wouldn't even have the same subnet scheme here with these numbers. I would have them something else inside here. I wouldn't even have them anywhere close to what this number was, because this number is being able to be seen by the public, and you don't want anyone getting extra information about your network. So just make those numbers totally different than these here. VLSM, Virtual Link Subnet Mask. It looks scary, and it can be complicated until you understand it. And I'm going to say it again, I've got a video in the description below on VLSM that goes into much more depth and detail than what I'm covering here. But let's just say that we have 7 subnets and they're required, 4 LANs and 3 WAN links, and the largest number of hosts in the building, D, with 28 hosts. So a /27 mask would provide 8 subnets with 30 hosts, and therefore support this topology. So we could segment this out separately. We need 2 hosts here, 2 hosts here, 2 hosts here, and then 28, 15, 20, and 25. So we could say 1, 2, 3, 4, 5, 6, 7. We need 7 subnets with at least 30 each. So we need 25 here and 28 here. So we could segment this out equally. However, we want to conserve IP addresses and host and IP addresses. So what we can do is the point-to-point links only need 2 hosts. We don't need 30 hosts in there. We only need 2. So what we're going to do is we're going to use VLSM. And the left side displays traditional subnetting. We did everything equal here. We split it up and we had 30 hosts each. But with VLSM, we can take and we can make segments or our subnetting smaller. So we can use a /30 or a /27 or a /25, and we can get different size subnets with different size of host in each one of those subnets. And again, the video below in the description goes into much better detail and explanation of how to do it. So this is an example of how we would break it up with the VLSM. We would make this one here a 192, let's start up here. We would say 192.168.20/27, which would give us 30 hosts. This one's a /30, which would give us our minimum of 2 hosts that we need. This one's a /30, this one's a /30, this one's a /27, 27, and 27. Or with VLSM, you can do them in any different segments. Let's say that we only needed 5 hosts here. We could make that even a smaller slash there and then have more host numbers left over. Now, when you're planning structure, you're planning your subnets and you're planning your networks, IP network planning, it is crucial. You need to spend a lot of time planning it out to develop a scalable solution for an enterprise network or even a small network. So to develop a V4 network-wide addressing scheme, you need to know how many subnets are needed, how many hosts a particular subnet requires, what devices are part of the subnet, which part of your network uses private addresses, which is going to need public addresses, and a lot of other determining factors. So you're going to need to do some investigative work. You're going to need to talk to people in the organization. They may not know. When you go to that person and you say, well, I'm subnetting my V4 network and I need to know how many hosts you have here and you have it here, they're going to be like, what are you talking about? And you're like, okay, so in this room here, how many people are going to need to connect with the internet? Oh, that's 5. Okay, so well then you know that's 5 hosts. They may not know what a host is. And then you know where your subnets need to be, and you plan all that out. You do some charting with it, and you maybe put it into a spreadsheet, or you do a flow chart to get everything laid out. You do your logical chart, your logical plan, then your physical plan, and you lay it all out. So you examine the needs of an organization, how many subnets you're going to need, how many networks you're going to need. You can perform a network requirement study by looking at the entire network to determine how each area will be segmented, how many subnets are needed and how many hosts per subnet, and then determine the DHCP address pools and layer 2 VLAN pools. And you're going to have 2 different situations. You're going to have one situation where you walk into an organization or somewhere where it's already have the networking laid out, and you're just going to have to work with what you have. And then you're going to have the other situation. Well, the other situation is you may just redo the entire network, which is going to take a lot of planning and time because you're going to have to take things down and reassign IP addresses and do all that. The other situation is where you're going to come in new, and that's the easiest because you get to plan everything out and you have to make sure that everything works right to begin with, but at the same time you need to plan for growth. Then we talk about device address assignment. You need to assign end user clients. Most use DHCP servers. That reduces errors, and you don't have to go around and assign IP addresses. Early on in my networking days, back in the late 90s, I worked at a company, and they had a small network and all of their IP addressing. This was before DHCP, and I had to go around to all the PCs and set static IP addresses. And we had a spreadsheet in the computer that showed us, and we would print it out, and we would say, okay, this person has this IP address, and then we didn't get it right sometimes, and you would get network conflictions. You would get IP addresses that were pinging against each other, and then neither one of those would work. So DHCP takes care of all of that. Then you're going to have servers and peripherals. Those are going to have predictable static IP addresses. You do not want to put those IP addresses in the DHCP pool. Servers that are accessible from the internet. Those are ones that are going to have public IP addressing. Then you're going to have your intermediary devices. Those are your routers. Those are going to have IP addresses on their outer and your inner gateway addressing. And then you have your gateway routers as well and your firewall devices. So when developing an IP addressing scheme, it's generally recommended that you have a set pattern of how addresses are allocated to each type of device. In other words, you're using a .1 for router points, or a .250. Printers have a certain pool, so you're using maybe 1 to 10, .1 to .10 for servers, and for printers, maybe printers have a different pool. Maybe they're all in the 25, or maybe they're all in the 20 range. So you just want to make sure that it's set so it's easy to know what's going on with your network. Some people in the security field will say, well, that's not very good, because then people will be able to figure it out. But if somebody gets into your network, they're going to figure it out pretty quickly anyway. They're going to scan your network and they're going to see all your IP range. So the whole thing about trying to get, do a crazy IP addressing scheme to keep hackers out, or to keep people out from a security standpoint, it really doesn't matter, because once they're in, they're going to scan your network and they're going to see everything anyway. So what did we learn in Module 11? We talked about IP addressing structure, that it consists of a 32-bit network address. The destination V4 packets can be unicast, broadcast, and multicast. They are globally routable IP addresses. They're assigned by the IANA. To reduce large broadcast domains, we use subnets to create smaller broadcast domains. We create V4 subnets using one or more host bits, such as a /8, a 16, or a 24, or even smaller. VLSM allows us to subnet on a smaller scale. It allows network space to be divided in unequal parts, and it begins by satisfying the host requirements of the largest subnet and then going from there. So when designing a network addressing scheme, consider internal DMZ, external requirements, use of consistent internal IP addressing scheme, and a set pattern of how addresses are allocated to each type of device. So this was Module 11, V4 Addressing, Part 2 of 2. I hope this material was helpful. I hope you have a great day, and remember to be excellent to each other.